Good evening. Good evening. Good evening. Merry Christmas. United States of America, world, Merry Christmas. 7:35 p.m. Eastern Standard Time on Monday, December 25th, year 2023. Merry Christmas, December 25th. Mark Kulak, Houstonic.live, broadcasting live from a corner of his room up in the northeastern part of the United States of America, about 30 minutes from Boston. Lifelong New Englander. And thank you for joining me on the program tonight. And this is just going to be like I always do it, one and done. I mean, sometimes I pre-record shows, but one and done. And I think tonight's topic is going to be very useful to a large portion of the audience. And the topic that we are going to cover is reviewing the definition of the word transfection. Transfection. This word has come up a lot. I've used it in titles before. Dr. Jonathan Cooey of Gigahome Biological uses it in titles. Unfortunately, very few people do. The reason why we are going to be reviewing this word is we have, and a few others, have emphasized regularly that transfection technology and mechanisms are being used for the current products, which are being described and advertised as vaccination products to protect people, whatever that means, against the disease of COVID or COVID-19. There's been, and I've been on this train as well, this little tug of war, if you will, of we should not call them vaccines, we should call them transfections. But in reality, a transfection is a methodology. It's a type of way of it's a procedure. Okay, and whatever the goal of doing a transfection is, well, that I suppose could vary. And most, as far as we know, anyways, products which have provided which have been described as vaccinations in the past did not involve using transfection, at least not directly or knowingly. Again, as far as I know. Perhaps it's best to say that this is the first era of vaccination that uses transfection or transfection-based vaccination. It's maybe, and if it seems as though that's a bit of a mouthful or a little bit too much to say, well, in this case, I think it really does matter. So we're going to review what the term means. I think I found a very helpful video that will review it, that introduces the topic. It's a little 4-minute how-to video that I think will be helpful to you, to hear it presented in another person's voice. It matters because, as we reviewed in a show I did a couple nights ago, I think it was on December 23rd, if you look at at least within the United States of America, if you look at the suite of, or the portfolio of products and vendors, manufacturers, which were providing immunizations for COVID-19 in year 2020, there was a tremendous diversity in the ways which these products worked. As far as some were electroporation, some were messenger RNA in a lipid nanoparticle structure, some were adenovirus vectored. They were all different ways of performing essentially a transfection. All of them involved finding ways to get some type of genetic material into a cell so the cell would do something. As far as I know, there was no variation in the actual genetic sequences within these products. And that is remarkably strange. I would have expected, if the narrative was as real as it is claimed, different vendors to have provided a massive portfolio of different types of proteins to be created with their products. And maybe some would be more specific and less specific, or more effective and less effective. I'm not saying that they should have done. But if the narrative was real, I would have expected to see a massive diversity in the specifics of what each product, within each product family, if you will. Instead, we saw one of this type and one of that type and one of that type. And it's sort of like the transfection steaks. It's so odd. And obviously, no vendor was calling out any other vendor, suggesting that there was a tremendous level of collusion here. So I think this does matter. And unless someone, I'm not saying you have to, from now on forward, only use the word transfection and no longer use the word vaccination. However, I think it is critical to understand what a transfection is and to use the term frequently, at the very least, because it will help flush out a very solid, and once you see it, you cannot unsee it, understanding of what was probably, hopefully, to be gained from COVID-19 products and where we are going from here. Okay, so we're going to start by playing, and hopefully he's cool with this, a short little video clip that Jonathan Cooey uses on his show from, I believe her name is Heather Haying. She is the longtime wife, congratulations, of Brett Weinstein. And she is a co-host on the Dark Horse podcast. And she actually, in this video clip, states her position on whether or not to use the word transfection or not to describe the COVID-19 products. So, research. Oops. Let's see here. Where is... All right. So let me just scoot out of the way a little bit. And again, thank you for joining, and hope everyone is having a very, very, very Merry Christmas.
Vaccine. If you think about it, if we're defining vaccine really liberally, and these COVID vaccines are vaccines, the flu vaccine is vaccine, okay. But actually, they're kind of cheating when they're calling these things vaccines. And anything with really rapidly fading efficacy, such that you need shots within a year, or Canada's saying 9 months, is, as actually J.J. Cooey's insistence, and I think he's right, on calling them transfections rather than vaccines.
And I agree. I mean, it is a transfection. I mean, I have big questions about most vaccines right now. Of course, the history of vaccinology is whacked. Let's just put it that way. There is some evidence to think about some of the past vaccine programs for things like smallpox that were performed at the immune barrier on the skin, where smallpox would typically be attained, if you will. And of course, the word vaccine means of cow. That's what it means, of cow. That's strange. Why? Because milkmaids, centuries ago, used to get blisters and skin infections, if you will, from cows. Well, how did that happen? It happened because they would spend all day rubbing their skin against the skin of another animal, and ultimately, the skin cells from the other animal are going to get buried into, little cuts, and if you will, of the people who were doing the cow milking. The immune system is going to kick in and is go, wow, this is a foreign skin cell. These are cow skin cells. These aren't human skin cells. And what they do is it causes a blister. That's the body's immune system trying to blister and cut off and remove foreign proteins. That is all it is. And there were early vaccinations. It seems as though one of the more ones that I've read about anyways was vaccines against smallpox or to protect people against cows. And it became practice for people who were working in those industries to need to or to desire to get those vaccines. And again, which weren't introduced via injection into the muscles. They were introduced on the skin. Were they incredibly effective? Were they foolproof? I don't know. Those are great questions. Okay. But until we do, there's a lot of documentation out there, and I'm not willing to, without digging into more of it, to say that they did not work. Okay. I'm just not going to go there just yet. When it comes to intramuscular injections, it's a whole different thing. Anyways, is it possible that transfection methodology, transfection technology, if you will, could someday be used to augment the human immune system to provide increased protection against something or strength? We can't say that it's not possible. We can't. We can't imagine the number of permutations. But at this time, what is being done with COVID is there's a product which is described, it's offered, it's marketed, it's sold as providing protection via a transfection technology. And which is very different than what has been done in the past for every other vaccine product. Not to mention we won't even go into the fact that it's being injected into the muscle, whereas supposedly COVID comes in from the air into the lungs. It's all whacked. Anyways, Heather was able to bring up that word. They don't mention the word very often, though, but thank goodness. And I thought it was pretty cool that Dr. Jonathan Cooey got a shout out in that video, and I think it's a good clip for him to play. And I play that also because this little battle of whether or not to use the word or not is real. And since almost basically every product that has been offered as a vaccine for COVID-19 is a transfection, why is that word a word that there seems to be a great effort to not say it? That is a red flag. Just say what it is. Just say this is transfection-based technology. Instead, it's all about, this goes in and it helps the body make the antigens, and then the antibodies come out because of the antigens and this and that. And no, they do not want to say that word transfection. Just say it. It doesn't change anything unless they want the general population to be unaware of a greater goal, a greater goal that is being undertaken here, bigger aspirations. Okay, so let's start off by going, and I looked quickly at the Wikipedia page for this a few different times. I think, and this, by the way, this video should be over by 8:15. Okay, I don't want this to be a super long video. If we go to Wikipedia, type in the word transfection. Oh, come on. TRANS. Transfection. No, I'm not going to give money. I've given money in the past, by the way, to Wikipedia. Transfection is the process of deliberately introducing naked or purified nucleic acids, think of the DNA, RNA, into eukaryotic cells. These are the cells of most mammals and most multicellular mammals and plants. It may also refer to other methods and cell types, although other terms are often preferred. The word transformation is typically used to describe non-viral DNA transfer in bacteria and non-animal eukaryotic cells. including plant cells. In animal cells, transfection is the preferred term, as transformation is also used to refer to progression to a cancerous state or carcinogenesis in these cells. Transduction is often used to describe virus-mediated gene transfer into eukaryotic cells. The word transfection is a portmanteau. I always forget how to say this word. A portmanteau of trans and infection. Actually, don't be bold, man. How many portmanteau? Sorry. The word transfection is a portmanteau of trans and infection. Genetic materials such as supercoiled plasmid DNA or siRNA constructs may be transfected. Transfection of animal cells typically involves opening transient pores or holes in the membranes of cells, the cell membranes, to allow the uptake of material. Transfection can be carried out using calcium phosphate, by electroporation, by cell squeezing, or by mixing a cationic lipid with the material to produce liposomes that fuse with the cell membranes and deposit their cargo inside. Transfection can result in unexpected morphologies and abnormalities in target cells. So, to review, this is the process of just getting genetic material into a cell, nucleic acids into eukaryotic cells. That's really it. Why? Or it doesn't really say why, how, when, and how it happens naturally. It just suggests that it's a process by which genetic material is being pushed into cells. And that's it. Now, cells, as you probably know, and again, I know we don't have all PhDs in molecular biologies, but we understand the basics. Cells are held together with a membrane. Cells have an outside layer that kind of keeps it all together, right? And the cell membrane provides a layer of protection. It's a barrier through which the insides are prevented from going to the outside, and what's on the outside shouldn't be going to what's on the inside. However, cells, of course, need to communicate with other cells, and of course, cells need to find ways to be able to absorb necessary materials to operate, and they need to expel things. That's based upon whatever the conditions are. So there are times when these solid cell membranes can welcome stuff in and send stuff out. If one were to just find some DNA and just throw it into a dish with some cells, nothing will happen. The cells will just be like, and nothing will happen. The cells need to be encouraged somehow to take in those nucleic acids. They need to be manipulated. Something needs to happen to the state of the cell membrane to get that outside material, that foreign, or I should say, the external nucleic acids inside the cell. That process is transfection. That's what it is. Now, the way transfection has been used, for example, with the mRNA vaccines, as has been described, is there is nucleic acids, such as the genetic material within or the messenger RNA within a lipid nanoparticle, which is like the Pfizer or the Moderna. Okay? And it is those lipid nanoparticles that surround the genetic material that create an environment, an electrical charge, a reaction when they come into contact with cell membranes, that the cell membrane will go, oh, interesting. come on in and join the party. Otherwise, the stuff would just float around. Much of the technology involved in Moderna is about those lipid nanoparticles. As much, probably even more than nucleic acids themselves. And before I play this other video, it's a 4-minute video, what you'll see is that the mRNA, which is really a synthetic exosome, but of Moderna and Pfizer, is one way of doing transfection. There are other products that have the nucleic acids in what it was described as a repurposed virus, a adenovirus, whatever that is or isn't. And again, the adenovirus shell, what is that? It's a shell, it's a membrane which can carry these nucleic acids into a cell somehow. So it is a forceful way to be able to manipulate cells to get them to uptake genetic material, nucleic acids that are outside of the cells. And the other method that you hear about is electroporation. The company Inovio, which has its roots in VGX or phylogenomics, and one of the companies that has actually been part of the Inovio tree was actually Genentronics, which has been making electrical equipment going all the way back to the 1980s, which have been used by biologists to, at least in a situation like in a dish with other cells, to create an electrical charge within the cell, within the fluid of the dish. And these electrical charge, based upon the power of it and the signal, the pulse rate and so on, would perturb the membranes of the cells, would weaken them and cause sometimes little holes, hence electronic poration, pores. And when the cell membranes are opened up and expanded and manipulated, this is not natural, of course, genetic material, nucleic acids outside the cells may find an opportunity to get into the cells. Again, it's an unnatural way of forcing nucleic acids into a cell. That's what electroporation is. Not using lipid nanoparticles, but just using a raw electrical charge and raw nucleic acids. But it's just another method. And what you'll see is between that, and so you look at Inovio and Johnson & Johnson, and Moderna and Pfizer and so on, and each of these products which came out to offer immunization to protect people against COVID-19 are all offered as vaccines. Each one uses a different method of transfection. That's the diversity. The diversity isn't, well, there's 55,000 ways of making a spike protein. We're going to try this way. We're going to try that way. We're going to move this code around here and that code around there. We're going to fold it this way. We're going to fold it that way. And why is there zero diversity in the way in the description of proteins to make? The only diversity amongst the products was the transfection method. Isn't that a little strange that no two vendors were using the same transfection method in the same how would you say strength, with the same type of lipid nanoparticles? That's really bizarre. Unless, of course, the goal was to use the population in a state of emergency to be able to get the regular human population to roll up their sleeves and to try this smorgasbord of transfection methods and to see which ones work and which ones don't. Which ones are more effective at this strength, which ones are more effective at that strength, which ones have stronger, more lasting effects, which ones have weaker effects, which ones seem to be easier to transport, which ones are harder to transport. It's almost like a great big test off. And because the impacts of transfection, while not necessarily inherently or guaranteed to be injurious, seems to be harder to tackle for the elderly. One of the benefits, if you're one of the psychopaths who is planning everything, viewing people as nothing more than numbers, is that if it does go terribly wrong, most of the people that will be impacted will be the elderly. And guess what? The elderly are expensive. Get rid of them. So, Merry Christmas. Sorry, I didn't mean to get dark, but so let's play that one video that I found. I think it's very, very helpful. It is on the site technologynetworks.com. I certainly haven't looked at all the videos out there. I think this video is on LabTube. Hopefully it's not on YouTube. And this is good because I sometimes get channel strikes if I play a video on YouTube for, sharing a video that's already been up there. But so let's do this, and then I'm going to scoot off the side a little bit more, and we'll play this little video.
This tutorial is provided to you by Transfection experts. Scientists use transfection as a tool to generate cell and animal models. In vitro, on isolated primary cells of cell lines. In vivo, on a carefully chosen animal model for subsequent validation in human clinical trials. Transfection is used to study gene expression and protein function by introducing foreign genetic material into a cell.
Gene expression and protein function. Or you could say the manufacturing of proteins. Proteins are manufactured with RNA, using RNA as a blueprint. Of course, it is the ribosomes within cells. And don't take these little cartoons too literally. When you see a cartoon drawing of a cell with a ribosome, each cell does not have one ribosome. Each cell can have anywhere between 10,000 to 300,000 ribosomes. Cells are like the sizes of galaxies. They're huge at this level. So when the blueprint for a protein, represented with these nucleic acids, is received into a cell, okay, the nucleic acids don't actually run. They're not actually executing code, right? They're not actually active computers. You can think of the nucleic acids as like the code on a disk. It's like the code on your hard drive of your computer or on your flash device of your phone. Just sitting there on itself, it doesn't actually do anything. The code needs to be made into a living, thriving thing that actually does something. It needs to be read into memory, and then the CPU needs to start doing things based upon it, etc. The transfer of dead code or just nucleic acid sequences into something that does something. The way that is represented in the real world is a protein is made. A protein is made based upon the blueprint, which is contained within the nucleic acids. The protein is manufactured by a ribosome. The way the protein is manufactured by the ribosome depends upon, of course, the blueprint of the protein, of how to make the protein. It also depends upon the DNA of the person or of the cell. And it also depends upon how that cell's DNA is being expressed based upon a variety of epigenetic conditions, happiness, sadness, hydration, diet, age, etc. The way DNA is understood, okay, can all be altered. It can be altered. So all of these factors go into how you could say how genes are expressed. It's one way of saying it. And through this expression comes a protein molecule. A protein molecule is what is spat out and constructed by the ribosome. And the protein molecule itself is not just like a dead Lego. Proteins live. They move. They have gears, arms. They are constantly in motion doing things. Proteins are moving machines. They're not dead inanimate objects. They're machines. And they act as a machine based upon the blueprints which were used to make them. Anyways, there was a lot there, but, and of course, you have to make proteins and then study what they do to understand the function. So going back to what she just said here, and the audio is a little bit muted, but we'll play it again. It's really important.
Human clinical trials. Transfection is used to study gene expression and protein function by introducing foreign genetic material into a cell. Why use transfection? Nucleic acids are negatively charged and are repulsed by the cell membrane that is also negatively charged.
Nucleic acids, DNA and RNA, are negatively charged. And of course, two negatives are going to, push each other away. Hence, the cell membrane, by having a negative charge all around it, is how it winds up being a nice, simple bubble. Otherwise, it would just crinkle up into a big pile of trash. You want it constantly pushing itself out so it is a nice, uniform, as round as possible shape. Also, these exterior pieces of genetic material have a negative charge, so they're not going to be welcomed in. Note, we are already talking about electricity.
Transfection is the mean to overcome this issue. Microinjection allows penetration of the cell membrane and nuclear envelope with a glass micropipette. This technique requires extreme precision and high levels of training.
The notes that she does not read are, so this is physically injecting. This is a sword going in, cracking open a hole and forcing the stuff in there. So microinjection or physical transfection is the most efficient technique. Of course it is, because you're definitely going into the cell and you're definitely going to inject something. No cell specificity. Well, other than, of course, you can see, I guess, the cell maybe. Limited scale, very slow and meticulous. These are the downsides. Expensive material needed.
Electroporation corresponds to the use of high-voltage electric shocks to introduce nucleic acids into cells by creating pores. When these pores stay open, cell homeostasis is lost and cells die, which is the main drawback of this approach.
And by the way, if you go back and look at the little picture, that is actually a Genentech device. This company was purchased by Inovio years ago. So Inovio is so wrapped up in what electroporation is, it's not even funny.
Corresponds to the use of high-voltage electric shocks to introduce nucleic acids into cells by creating pores. When these pores stay open, cell homeostasis is lost and cells die, which is the main drawback of this approach. Transduction refers to virus-based delivery of nucleic acids in cells. Scientists insert genetic material into the genome of the virus, which requires expertise and specific lab biosafety levels.
So transduction would be the Johnson & Johnson shot. Genetic material contained within a virus shell. Now, if you don't believe pathogenic viruses are out there, I think we're probably in sync with that. However, cells within multicellular organisms do communicate. And they communicate by creating little pockets of genetic material, or called extracellular vesicles, which are then how would you say, budded off by one cell and received by other cells, which need to receive those messages. All cells in multicellular organisms communicate. Multicellular organisms did not wait until they had arteries and a nervous system for the cells to start communicating. They needed a way to go from single cell organisms to pools, if you will, of 200, 300, 10,000 individual cells, and then eventually specialty cells were realized. Either way, even in animals such as humans with specialty cells, our cells are still constantly communicating. Hence, most of what the world has thought of viruses is really just cell-to-cell communication. So some of this can be repurposed. So it's sort of a synthetic way, sort of getting genetic material into a cell. But they call it viral infection or transduction.
Chemical-mediated transfection refers to engineered polymers that encapsulate genetic material that are internalized into cells via endocytosis.
And that, what was this? Boys, they went over that pretty quick. Play that again. Because this is Moderna.
Chemical-mediated
and
transfection
Pfizer.
Refers
Chemical transfection.
to engineered polymers that encapsulate genetic material that are internalized into cells via endocytosis.
Oop, that's it. Move along. It's noteworthy that this video was published in September of 2019. So clearly this is a video that someone wanted to put out in a timely manner to control that narrative.
Chemical-mediated transfection is the easiest method to transfect cells. Efficiency, easiness of use, reproducibility, and cost-effectiveness are ensured.
I didn't watch it to this part. Okay, so what are the main advantages of transfection? Efficient at all scales, easy, fast, and adaptable, reproducible, and cost-efficient. Oh, so this video is effectively saying that this chemically mediated, or the lipid nanoparticles surrounding the genetic material that you want to get into the cells, is freaking awesome. It's efficient, it's fast, it's reproducible, it saves you money.
Let's focus on chemical-based transfection. Nucleic acids like DNA are overall negatively charged molecules. Opposites attract, and what better way to encapsulate DNA than by using a positively charged polymer? This engineered polymer condenses DNA into positively charged nanoparticles that can interact with negatively charged cell membrane. This interaction triggers cellular uptake in endocytic vesicles that rupture in the cytosol once the polymer induces endosomal escape. The overly represented exogenous DNA in the nucleus is actively transcribed into mRNA and translated into the protein it encodes for via the same protein expression machinery that the cell uses.
And of course, what they're saying is different types of proteins that you could make enzymes, antibodies, structural components, or other proteins. What this doesn't say is you could also make an antigen. You could make something which we would identify as the spike protein. However, why would you make a foreign protein? That's a dumb idea when you can just make an antibody directly, at least hypothetically. And as our last few weeks of videos have shown, this is where it's all going, using transfection to make antibodies directly. This is the next generation of products, making antibodies directly. Finding them with the antibody to make with big data analytics in a company like Abcelera, and then using mRNA or like a Pfizer or a Moderna product, or who knows, maybe even a Novio electroporation in the future. A patch at a skin, as Rick Bright said, as well as David Hone, and make antibodies directly. Again, I'm not saying the antibodies are the end all be all. Either way, this concept of Transfection really describes and as it's reviewed here, the diversity amongst all the products of COVID-19, at least within the United States. I don't know what every other country is doing. It's almost as if it was a great big horse race to see which ones worked better, which ones did more damage. I think eventually someday we will reflect back and realize that some of these products might have been known to be more dangerous and might have been introduced intentionally in certain areas or in certain countries. I think that's possible. We'll find out, though. However, the focus on the protein that is created, the spike protein, takes all the focus off of this. Instead of focusing on, the HIV inserts or the DNA contamination or the this or the frame shift or the uptake or all that other crap. All you need to do is ask, why is there such diversity in transfection? Because that seems to be the only thing that was really being tested at all. I will also assert that I think it is unlikely that there is very solid understanding about how any particular genes work at this time. I think that there may have been some correlations noticed, but the state of the art of science is being way oversold right now. Not only is it not really well understood how the human genome works, or even how proteins work, or even how the ribosome works, but let's agree that there is not even a universal understanding about how to get cells to uptake genetic material at all. And until this can be done, there is no gene therapy. Until this can be done, there is no DNA modification. Until this can be done, there is no way to reliably and effectively make a cancer vaccine. This is the most fundamental part. I can't emphasize how important it is. And with the U.S. having invested about as much into gene therapy and the AIDS vaccine as we have our space program, trust me, this is really important. And there just happened to be a window of opportunity based upon political environment or increases in nationalism or political sentiment, or maybe it's due to the world demographics, I'm not sure. However, the things they talk about at Davos and those other events isn't Epstein's Island. It's not how to have more codfish off of Newfoundland. It's nothing like that. It's about how to stop cancer so that they and their kids can live. And the only way that's ever really going to happen is if this technology is understood. And the only way this technology will ever be understood and figured out isn't by simulating it in computers or testing it on animals. It's by testing it on humans. Anyways, to review, the Wikipedia page on transfection is pretty good. This is a great video here. Cell Science, published September 1st, 2019 on Technology Networks. You know what the word transfection is. Know that what is being done now is an attempt to create immunization or to provide vaccination via transfection. I won't make a comment on how effective it really has been. If you watch my videos, you know my thoughts on that already. It may be possible someday, can't rule it out, that there could be tremendous benefits to transfection technology. Maybe. And we, for the record, are not opposed to it at all. However, the undisclosed testing of this on people, with them being unable to be aware of the risks and the rewards, or to have an above board agreement upon the risks that they are taking and receive appropriate compensation if they are damaged or killed by it, is completely unacceptable. Completely unacceptable. So with that said, I think this was a useful little show. It's 8:21. That's 50 minutes. I don't have a chat window open. I received a couple of gifts today on Patreon. Thank you so much. God bless. I have a couple letters to open. Maybe we'll find some time to do that tomorrow. Again, 16 days in a row right now. Thank you, everyone, for all the support. I hope you have a blessed Thanksgiving Day. And thank you, Lord. Thank you, Lord, for this day. Anyways, thank you, and for the next year. God bless everyone. Love you very much. Oops. We want that one. There we go.